let's go to the multiple. I'll close this multiple now. So with the multiple, you don't need, there's no limit on the number of variables you can use. Whatever number of variables you have in your data, as far as I'm concerned, I haven't encountered where I'm giving a limit on the number of variables to use. Because it's going to do linear combinations and choose the ones with the highest, the higher R squared at each scale and show them to you. Okay, so let's see how it comes out. For consistency scale, let's change this to WF as we did the other one. Okay, so okay, let me see. Let's change the scale and see. Oh, wait, the scale should be 4, right?
Yeah.
Yeah, so let's change that and see. Oh, great. So it was the scale. Problem solved.
Okay.
Great. That's a relief. Mm-hmm. So this is what I was telling. I was trying to explain. So let's look at the plot.
With a convergence?
A little bit. You cannot rule that one out because we started from, so let me see. There's a reduction anyway, because here, this one.
Yeah, it's coming down.
It's higher.
Yeah.
But this one is higher than this one.
Yeah.
So we get close to about 80, then there's a drop to about 65. So you have to explain that one. Why is that the situation? Why is that the case? Okay, so in the short term, we have about 45%. Then we go down to about 25. So we are saying, what is what you're saying? We're saying that in the short term, the correlation between these 5 macroeconomic variables can be explained to the degree of 40% by just the variables. Everything else cannot be explained in the system of those 5 variables. And that goes down to about 25 and shoots all the way to almost 80, then drops a little. So integration is high in the long term. Okay. And all the correlations are significant, we can see. One thing, yes, this is what I wanted to show you. Now you see these, the variable names here. The variable names there. You cannot interpret them because they are portraying something that is actually not true. They are portraying potential leak and lag. So the variable names on the x-axis, you should ignore them because they are not portraying something right. I will show you why. Because when you decompose, they add an extra scale to it. And that extra scale will pick up another variable. So it distorts the order of the variable in the table. And I'm going to show you that one shortly. Okay. So we can explain this plot, ignoring the labels at the bottom. So the safe way is do not interpret those ones, just leave them if you don't have a way of removing them. But you can Photoshop and remove just the names. Everything else is correct. Otherwise, what you can do is to extract the coefficients, which we are going to see shortly, and plot this in Excel. It's just simple. You put them in the columns and plot. It will show exactly as it is here. Or there's a manual code that will plot. You go through the decompositions one by one, you transform them, do all of that. And then by the time you finish and get this plot, the names will not be there. Okay, so that's for the wavelet multiple correlation. Okay, let's close it. Let me clean. Come on, let me clean the. Okay. So now let's go to the cross. Oh, let's save the output first. So let me explain this one a bit. See, you see max R, this is the localizations. We had how many skills? How many skills do you have?
For my data, 4.
Yes, 4. And so, but if you come here, see 1, 2, 3, 4, 5. Okay.
Yeah.
And you see that the highest correlation was about 80%. Where is it? Yeah. Where is it? So it's almost 80%. This is the correlation. Let me bring the annotate again. So this is the correlations. So these are the correlations. And this is the lower boundary. This is the upper boundary. So you realize that this last scale is not part. You don't need it. And it's showing almost perfect correlation, which is not the case, right? Now each one here, this one is for the first scale, this is for the second scale, third scale, fourth scale. And this is supposed to be for the fifth scale, which we don't need. And each one of these numbers is telling us of the location in the table of the variables. Okay. Each one of the numbers is telling us of the location of the variables in the data. So 3 is, I think, ER, 1 is PR, 3 again is, and 4, you know. So, and those are the ones represented in the plot that you saw at the bottom. So you have to ignore the plot, those names there, because this large scale is distorting the arrangement. That's why I say you ignore that one. So what you can do is, since you can plot these correlations itself here, you can just plot them. Let me see, come on. WMC, yeah. So this is it. You have everything you need. You can just plot them in Excel, and you have the same plot without having to deal with this. So this is not needed. Yeah, and this is your correct correlations with the boundaries. Are we good? How many lines do you think we will need? This is quarterly data. So if we stay in a year, 4 should be fine, no?
Yeah.
Yeah. So each will represent a month. So that's L max. You can give it any name, it doesn't matter. Supervision back. No. Okay. Or come back. Okay, so for consistency's sake, let's make this WF, 4 on each side, and the middle will be that's 0. Okay. So if that's acceptable, we can run our okay.
Yeah.
So now look at the bar on the right here. This is telling you of the correlation value based on the color. So here, this tells you blue, the deepest blue is 0.2, and then it goes up all the way to 80% darkest red or whatever, deepest red. Okay. So when you come to the plot, what you're looking at is that what color is showing here.
Okay, I get it.
Okay.
You trace it to the scale here.
Okay.
Yeah.
Okay.
So it's around, let's say, 64-ish.
Yeah.
Okay. Okay, if you
cut on 0.
No, it's on 0.
Yes. So it is neither leading or lagging.
Neither leading or lagging. Is the exchange rate that is more of leading variable?
Leading at lag 1, and it has the strongest localization, 80%.
50%.
So you see the red color, and then you check the map, the scale. That's 80. So
okay, so the next one is prices or CPI. Is lagging.
Yes, lagging all the other variables.
Yes.
And the localization is
this is around
maybe close to 60%.
Yeah, or 60%. And it's at lag 4. Yeah, lag 4.
You have different dynamics at different scales. So.
Oh, I see. So the next one is the exchange rate, and this time the exchange rate is leading at lag 2, and we are looking at the correlation of maybe around 31 or 32.
Yeah, something like that.
Yeah.
So that's it. Then now, once you know that, I can go into the practical aspects and the policy implications.